we are going to see how we can make some more improvements into our encoder decoder architecture so that our performance increases. Okay. First improvement that we can make in the above setup was use better initial word embeddings. We used one hot encoding above, so we can use word to vec instead of that. Word to vec or glove or TF-IDF, which captures the semantic meaning of the words in a better way. Second improvement that we can do is use LSTMs, use a multi-layered LSTMs. These are called deep LSTMs. So the output of the words at each time step goes through another layer. In this way, the semantic meaning of the sentence is captured in a better way. Here, another improvement that we can make is reversing the input sequence of the words. Okay, this was suggested in the paper titled Sequence-to-Sequence Learning in Neural Networks, and it was published in the year 2014 by Ilya Sutskever and two other brilliant scientists. The suggestion that they made was if our input sequence is A, B, C, we are going to feed this sequence into our encoder block in this order. We reverse it. Okay. So in the first time step, we give C, then A, B, then A. Then finally, the embedding would be ready for the entire sequence, and then it would go through the decoder block and the output sentence would be produced. Output sequence would be produced. So by reversing the order of the input sequence, they got improved results, improved performance of the model. This also reduced the inference, minimal time lag that they had during inference. Minimal time lag was the amount of time that the model takes to process the entire input sequence, produce the vector, and then finally start generating the output sequence. So all the time that it takes between the first step and the final step is the time lag that we get. So this time lag got minimized by large amounts when they reversed the order of the input sequence. They haven't explained this in a very convincing way in the actual paper. Few reasons that they have given are basically if we reverse the input sequence, it creates a bunch of short-term dependencies between the input and the output. Okay. Let's say this was our input sequence. They took English to French language translation task as the target task that they wanted to achieve. Let's say ABC are few words in English. It gets transformed into alpha, beta, gamma. Let they be words in French. So let's say this was the initial time lag they had. Now if we reverse the input sequence and try producing alpha, beta, gamma, the distance between A and alpha is significantly reduced. Okay. In, let's say, time step 3, C was going in as input, and time step 1 A went in as input. Now the gap between the time step in which A was given in as input and in which alpha is produced is very less. Okay. If you see the average distance between all words, if you take out the average, it will be the same. Only the distance between A and alpha is reduced significantly. So this will create a bunch of short-term dependencies between A and alpha, basically between our input, start of the words of the input and output sentence. So the minimal time lag has been reduced significantly, and the generation of the output sentence would start almost in no time. So this is how it improves performance.